Traditionally, this works for about 30 seconds and then blows up. But this may actually be success. So this is the inheritance class if you're joining in. All right. So last week, well, not last week, last time we met, not considering the midterm, we talked about inheritance. What is inheritance in Java?
It's like importing code, not from the API, but it applies the same project.
Importing, yeah, not necessarily importing code. It's not importing, but still, you're on the right track. Extending, yes, using other code that's already written. So in what example could you think? Can you think of an example how we use inheritance in Java? And well, first of all, why do we use inheritance in Java? Yeah, Ellis.
You want to repeat code that you already made.
Yeah, if you want to not repeat, but if you want to use code already created. So think of it as something you already wrote, and instead of rewriting it again, you're borrowing parts of that code and just making the new code available that you could use for your particular class structure. So let's give an example. Can you think of an example of an inheritance structure in Java, Ellis?
I can give an example.
Hmm?
Let's say you have a candy class, and then you have let's say Jolly Rancher class. So let's say the properties of candy can go to Jolly Rancher.
Yeah, exactly. So candy is a class. And then you have the Jolly Rancher, which is also a candy. It has more specific properties that applies to it than more generic candy. But there's some things that all candy share that you can take advantage of and borrow from. Can you think of another example?
Vehicle and car.
Vehicle and car. That is. Although I like your Jolly Rancher example, I like the vehicle car better. Vehicle. I have a vehicle class at the top, and then how I would demonstrate inheritance, I would draw a line down with an arrow to it and say car class, like that. So how does that work? Well, if you look at it, the car class is a more refined version of a vehicle. Like a vehicle, a car is a vehicle, right? But it is more defined. I can't say, if I go into a shop or a store that sells ATVs, jet skis, cars, transports, and motorbikes, and say, I want to buy a vehicle, that would not be enough information for them. It would not be enough information. I would have to give more information in order for that to happen. So in this case, I've created a subclass called, or a more specific subset of vehicle called car. I can go in and say, can I buy a car? And they'll say, sure. What other kind of vehicles do we have? What other kind of vehicles do we have? Yeah.
Helicopter.
Right?
Helicopter.
Helicopter.
Motorcycle.
Let's leave the helicopter out for a second. Keep that. I want to come back to that, but leave that out for a minute. What other kind of vehicles do we have?
Jolly Rancher.
Jolly Ranchers. Is that with or without turbo?
Turbo.
Turbo fit Jolly Ranchers. Yes, I'll take one of those. Maybe not. What else? What other kind of vehicles? Yeah. Trucks.
Like an F-150, like a pickup truck.
Now, with that, yeah, okay, I'll buy it. Truck. What else?
Motorcycle. That's snowmobile.
Snowmobile. Three classes. Now, is there anything you can look at for all these classes that they have in common? I want to see a couple things they have in common.
An engine.
Engines. What else? What do they have in common? Sorry? Body. Transmission. Tank.
That's like electric motor, like electricity starter, battery.
Electrical system.
Yes.
Absolutely. Let's stop at that. What's that?
Wheels.
Snowmobile
Wait a minute. You're from the southern European climate, so this is your first winter, right?
Well, we have winter still, but yeah.
Okay, have you seen, do you know what a snowmobile is?
I see one.
Yes.
I have no idea how they move over the streets.
Oh, they don't have wheels, they have little skis, and there's
Yeah.
like a little
Skis
drives,
and a belt.
belt, yeah, that drives you, okay.
Oh, the belt, okay.
There's a belt that drives you forward, which is different.
But in theory, though, the
Okay,
wheel drives the belt.
Yeah, something that drives it.
There's an axle,
Ancient.
but there's no tire on it.
No.
And there's no hub. There's no steel radial belted tire or anything like that on it, right? So there's a difference. But these things here,
Thingy
Are
that
all-
moves the vehicle.
was that?
Thingy that moves the vehicle. A thingy that moves the vehicle. Instead of wheels. So it can be wheels, it can be.
I think.
It's a technical term.
Yeah, okay, I was beyond me, I didn't capture that, okay. Yeah, a thingy, we'll put that on as a variable, sure, we have thingies. That can be a super class of a gadget. Okay, so these are all items that, of course, there's more, but at a 2-minute span, these are things that we can identify. So 1, 2, 3, 4, 5. We have 5 items. If I have an accessor and mutator method for each one of those, how many methods did I going to need?
10.
10, yes. 5 times 2, which is 10 fields. Sorry, 5 fields and 10 methods. Now, if let's say we had a couple other things we need to be able to do. What else is? So that's what data we have in here. What does all of these do that are common? What does all these vehicles do that are common for all of them?
Transport.
So drive, yeah, drive, transport, like transportation, I mean, like moving forward. Drive, can we consolidate them? Okay, drive, what else?
Consume fuel.
Fuel, consumption. Well, do they all? Yeah, the fuel use, consumption, rather fuel use. What else? Start, stop. I turn the engine on and off. And there's one thing I noticed in assignment 1 is that a lot of students turn their engine on, but never turn it off. I was pretty lenient with the marks on that, but that's a bad problem. If you let your engine run until you run out of gas, it's going to overheat, and you're going to have lots and lots of mechanic bills. So keep that in mind as if you start your car, like in real life, you need to turn it off as well. It's really go, Keith. What else? What else is common? Steering, navigating, we'll call it navigation, steering. All right, so here's another 1, 2, 3, 4, 5, another 5 methods. So at this point, we've figured out we need about approximately 20 method for, let's say, an odd about 10 so variable. So, because we have to get, yeah, so we'll say 10 variables and 20 methods altogether. So if I were to create these individually and write code for each one of these individually, I would have to write code 20 items here, 20 items here, 20 items here, and 20 items here. Because all of these vehicles, we determine all these features all belong to all vehicles. What inheritance does, what it does for us, is it allows us to consolidate all of them into the single top level class, which is vehicle. This here, what you might remember what this is called?
Superclass.
Superclass, yes, it's called a superclass. A superclass called vehicle. A superclass is at the top level of all classes in an inheritance hierarchy. Can you think of a top level class? What is the topmost class in Java that is always going to be a superclass of everything? Object, yes. Object would be the, in this case, we wouldn't have another definition, so object would be the superclass in this particular definition. But vehicle is the superclass. What about these classes down here? Snowmobile, car, and truck. This is a superclass, and what are these?
This class.
Hmm?
This class.
Class? No. They are classes, but they're
A child.
child, it is a child inheritance child model, but parent and child model, but it's called a subclass. Because a subclass is what's inheriting from a superclass. So we have superclasses at the top, and anything that inherits from it is called a subclass. So what's the benefit of inheritance then? Why am I using this? Seems like a lot of extra work. Why am I doing this?
It's actually simplifying the structure, improves debugging.
So elaborate, how are we doing that?
So if something is wrong with snowmobile, instead of writing a single code for everything, if you don't know that there's something wrong with snowmobile, by having modularized and save and atomize to a small level, helps you identify the error in just one section and fix it. Only in a subclass, or depending on where that's happening.
Right, now, you're correct, but you're reversing it. You're saying like the more refined snowmobile, if it has a problem with it, it's easier to find. Yes, it is, but if I were to have 20 methods and fields in here, in all of these, you're on the right track. Let me come back to your thought a bit.
Well, I would put the drive fuel using accelerating vehicle,
Yes,
while in snowmobile, car, and truck, I would just use a few extra items that are unique to each other.
right, exactly. So what we do, why we have a superclass is because we take all these things that are common and they go into the superclass. So vehicle will know how to do all of this and all of this. I have all these variables. So all the 20 things are stuck up here only, not in the subclasses, which means that this vehicle class will have the root of the code. All the code that we require to do all these things will be put in here. And what we're doing is in Java it's called, we're extending these classes from vehicle, which means that by extending them, we are allowed to tap into whatever vehicle knows how to do. It's also given to the kids. I'll give you an example. It could be a little bit abstract because my kids tend to not listen to me. But my kids are my subclasses, if you can say so. So all my wisdom as a super class or super parent, they ask me, and I teach them things, right? I teach them how to listen. Although I haven't done a great job of that. How to listen, how to do things, and they come to me with questions, and I'll give them information how to do things. So they ask me for all my knowledge, and I give it to them, collectively give it to them between my two kids, and then they know how to do things. Later on, although my son is a very, very good programmer, luckily won't take my path. He wants to do something different with his life. So he's going to go and do his own thing, which means that all I taught him is he knows that he's going to do his own refined little thing, which means that he doesn't have to relearn everything that I learned because I taught him how to do it. So same thing here. I'm saying my subclasses, I'm saying, okay, don't relearn what vehicle already knows. Tell vehicle you want to use everything it knows, and then just refine down here what you need to do. Which is coming to your point, Gabrielle, because now let's look at what can a snowmobile do that a car and truck can't?
Drive across it. Bit of water.
A bit of water, I don't know.
Well,
Believe it or not, it must be.
off-road.
What's that?
Drive off-road.
Yeah, I have a truck with 4x4 and
What cars usually can't. Like,
yeah, okay. Cars can, yeah. What can a snowmobile do that a car and a truck can't?
They can travel on rough terrain, on like rough snow terrain.
Travel deep snow, is that what you meant?
yeah.
Okay, so travel deep snow. It's intriguing when you go up to Ranking Inlet. Anybody ever been up in the Arctic? No? Fantastic. You should everybody at least take one journey up there in their lifetime. Amazing. It's so cold. It's unbelievably cold.
Yeah, that's
No, it is, but it's beautiful up there because depending on etc. I'm not going to get into that, but if you get a chance to go up to the northern hemisphere, like go on the Arctic Circle, take it. It's a lot of fun stuff going on there. A lot of cool stuff.
more cold stuff.
Oh, cool stuff. Cool. No pun intended. Yeah.
Is there anything up there? Like,
What's that?
Is there anything out there, like houses or YouTubes or?
Oh yeah, there's
Snow.
clusters of 5 homes together. Not a lot of people move up there because there's not a lot of people work up there mining and so on. But yeah, there's not very. It's not very busy. You don't have to wait at the red lights. Let me ask. I'll tell you that. But it's a cool experience. A friend of mine was a pilot. He flew up there weekly to drop, and that's.
I heard that people go there to do mining, gold mining.
I'm from Sweden originally, and it's a very northern part of Sweden. I was in the military. We were called up for exercises, and it gets very cold up there. And there was about 6 or 7 feet of snow, but because it was so far up, and that when the sun came out, it crusted the layer of snow on the top, so about 3 or 4 inches thick of this crusted snow that was almost like ice. So when that happened, it got so warm up there that we would actually go in shorts. Meanwhile, it was very cold, but it's a unique experience. It's a good chance to do. However, snowmobiles, they don't have cars up there. Very few people have cars up there. It's just simply a snowmobile environment that people do around. So definitely the travel deep snow is not definitely not recommended if you have a car. You can. I have a truck and I've gotten around, but I've also gotten my truck stuck in deep snow, trying to get too enthusiastic. So definitely not that valuable. What about car? What can a car do that a snowmobile and a truck can't?
You can transport multiple people, not multiple.
Yeah, transport people. I guess this
Snowmobile and truck can do this.
yeah, I can do the same thing. So
By truck, you mean pickup truck or commercial 6-wheeler?
what do you mean by truck?
60-wheeler.
Whatever. Let's shake it up, go for the semi.
Yeah, I'm thinking more of a 5-ton truck, like a delivery truck.
Okay.
Oh,
That's what I had in mind. Because a truck, half-ton truck and the car is really not too far apart, right?
I guess. I would have thought, like with cars, you can definitely transport more people. With trucks, you can carry like really heavy loads. So at the very least, like if you have even a smaller pickup truck, it's much easier to if you were moving from one apartment to another, it's much easier to store your belongings in the back of that truck rather than in your car. Even if you just put the seats down, it's just easier in the truck.
There's more that a truck can do than a car can.
Freight options. Freight options of the truck are better. Now, mind you, my truck can seat 6 people. Because I have the biggest cab we can. Don't ever buy a truck. You're right. You're moving for people all the time. Definitely freight options are better. Travel to deep snow, which you can't really do with the other two. And then what can a car do? That's the drive. Was that yeah, fit in the drive-through? Your car can save you gas. How's that? However, my point is that a snowmobile can do all this that a vehicle can do because a snowmobile is a vehicle, and because it is a vehicle, and that's the key, is it is a relationship. Because it is a vehicle, it can do everything you write in a vehicle. Because a car is a vehicle, it can do everything you write up here. And because a truck is a vehicle, it can do everything that a vehicle can do without you having to write that code in any one of these classes. So those classes don't have to have code for electrical system, tank, transmission, engine, body, steering, stop, start. You don't have to have it in there because it belongs to the vehicle class, and you can just, because it extends and it uses that, it simply doesn't have to use it. So very, very important part. What we can do is we can create our own functionality in our subclasses. We create our own functionality in our subclasses that is more defined. Now, travel deep snow. Because my snowmobile can travel deep snow, does that mean all vehicles can travel deep snow? It's not a reciprocal relationship. It doesn't mean that just because snowmobile can, the vehicle can. So you can't say a vehicle is a snowmobile. Not all the time. The vehicle could be a car, it could be a truck, it could be a bicycle, whatever. It could be anything. But in this case, a snowmobile is a vehicle. So inheritance in this sense is that we're creating a superclass that has a lot of functionality that can be applied to multiple different classes, and then our subclasses specifically borrows from that level. Can you think of an example of how we have done that in class, where we can put that into one of our classes? We did. So I don't know. Everybody wasn't here last week when we did the Ignition class. Can you think of something that that we can do. So in our class, we created a customer and an account and a main. Okay?
So, what about instead of having, what we did with the account is we would have like a string describing the type. What about making a subclass called checking account?
Absolutely.
Or, savings account.
So I'm going to erase this because we won't need it. Let's talk about our account class. And then we created a, what did you say, checking account?
Yeah.
So what are some things we have that is common? We're gonna have, in fact, what we're gonna do today, we're gonna create a couple more accounts. We did checking last week, last time, but we haven't done a whole lot with it, so we're gonna write more code into that to make it more comprehensive. We're gonna create a couple other account classes as well to add to that. What are some things, some other account, we have three, let's say do three account types altogether. So we have checking, that's one subclass. What else? What other sub-accounts do we think of?
Savings.
Pardon?
Savings.
Savings?
Debit. Insurance? Debit.
Can you go to your bank and get insurance? You probably can.
Yeah.
In fact, you probably. Yeah, but, let's leave insurance out for this. What do you say?
Debit.
Debit. I think you think about a credit account. Like an account that you can use, like have a credit. Define what you mean by debit.
A debit is simply a balance that you use your online account that you can use anytime. Also you have
Money that you own or money that you have available that belongs to the bank. You pay.
Not mine.
Okay, that would be a savings or checking account. You would have a debit feature attached to this where you can debit your account. But there's another way to do it. Pardon me?
No, credit.
Credit, yes, credit. Let's do a credit account. Credit account. So what are some things that are unique or that are common among all our subclasses that should belong in this unit class?
Does credit have a balance? I'm not sure.
If you have a credit card, you likely have a balance if you use it.
I've never used a credit card.
You're a student, you have a balance on your credit account.
Oh, yeah, I don't have, I don't have a credit card. I think I have one, but I've never used it.
But even if it's zero, it's still a balance though.
You can have even a positive, like you can prepay credit cards and then use it and then you'll get interest on the,
Okay, so here's a scenario where you can have you can owe money on a credit card, you can have a surplus balance. So that means, yes, we definitely need a balance. So a balance, I like the idea of having a surplus. You deposit money onto your credit card. Do they pay you the same interest they charge?
I don't think you can change interest,
No.
it's like, you pay it, it's like debit, it's like a debit.
More flexible debit.
Yeah,
But do they
I
pay
don't-
you interest?
No,
Because if they pay me
but I'm not sure.
20% interest, I'll put all of my on a credit card as a surplus.
No, they don't.
No, too bad. Almost had an idea. I'll retire early. Okay, so definitely we need a balance, right? What else do we need from an account standpoint?
Withdraw.
Withdraw. Yeah, what else?
Well, if you have a credit, you can't really withdraw on it.
So it'll be a debit credit rather than a withdrawal deposit. It's the same scenario, just different wording.
Yeah.
If you have a credit card though, can't you go to the bank machine to get money?
But I think though that the logic, yes, you can, but the logic is if you pay for something on a credit card, that's in theory a withdrawal, which is a debit.
Yeah, there's not a debit, you still get charged interest on it, right?
Yeah.
Okay, so assuming the credit card in our bank, you can't pay it, you can only take money out with it. I see what you mean, but it's gonna complicate matters a bit.
Well, that's why I'm saying change the wording from withdraw and deposit to credit and debit, because
Oh, I see,
every one of these you credit or debit.
I see what you're saying, yeah, okay. Credit, which is
Which is deposit.
deposit. or debit which is,
Withdrawal.
I see what you're saying, this terminology at this point, yeah, absolutely, yeah. What else, Alice? Oh, we just, well, I'm about to ask a question, this is a bad move for you, because you're gonna get that, you're gonna get signed a question. What else can I put? So balance, credit, debit, what else?
Interesting.
Interest, absolutely. Anything else? An ID number, unique number for your account? Absolutely. So account number? Anything else? Lots more. Like the banking industry, I've worked with computer programming in banking. It's unbelievable the amount of data they need, more than what's logical. But as business people, that's people love it. Yeah. There it is. Anything else you can think of?
Number of accounts.
Number of account. Now let's look at this. Where should we have that information?
And customer.
In the customer, right? Which is outside the scope. Now we wouldn't have this. This would not work. We wouldn't have this. I ran out of room. We'll do it again.
On the same level or hierarchy. It's not the law.
Can I do this?
No.
No, I can't. Why?
Because our customer is not.
That's right. That's right. It is. You can call it an account, but really it isn't, because the customer is a single or a self-independent entity in this program. It doesn't have an inheritance model from an account in this place.
So wouldn't then, rather than having a subclass or a superclass of account, shouldn't that be customer? Because, no, it shouldn't. Okay, I'll be all right.
Because if you do customer operations, that's different from account operations, right? So absolutely, yeah. So we'll leave that out, but yeah, we'll leave, that's fine. So at this point, we have five variables, or five withdrawn deposit these are methods. And then balance, interest rates, and account number are all variables at this point. What's unique with a credit? What changes? Well, first of all, what is this? Yeah, what's the same? All of these are the same, but what changes in a credit account that's different from what we have in our accounts?
Available credit.
So credit, so balance,
Well, no, your actual credit limit.
credit limit. So okay, so we need to have a credit limit. What else? What else changes?
Interest rate.
I'm thinking interest rates, because I know my savings account, which is just not really a savings account, it would be a joke to call it. I can save money in there, but I don't get any interest on it. Any interest I gain is always from investments. But my interest rate is going to be.
Shouldn't that be in the credit checking and savings level rather than in the superclass?
No, we want to leave it as an interest rate. The variable.
So it's a standard interest rate then?
Yes, it's the interest rate variable that holds the value, right? But we can change that. We can override that in our subclass. We can override it in our subclass by creating our own. So in this case, we're going to have an interest rate. Interest rate that's different in here. Put that in here as well. That's different down here, but in savings, we're going to use the same one. So what else? Let's look at that code. Let's look at it let's look at the account class right here. And let's make some modification to what it is we need to do. Just going to validate this real quick. Awesome. Okay, great. So we have an account num variable. We have a balance, account type. Now we can take that out because we won't need account type in here anymore because we're going to start creating subclasses. We have a creation date in here. We can leave that in there. That's okay. But what do we need to add? Interest rate and account number, which we have account number. So interest rate. So private, double, interest rate. We can modify, or we need to modify our constructor to take out the account type. But we need to provide a balance in year, month, and day when it was created. And remember that our service class is still providing our account number from the service class into the account class. So at this point, we have our overridden constructor. Now, do we need to modify our constructor parameter to take more data?
No.
At this point, no. You say no, why?
Because for interest rate, you wouldn't have to change it, you just fix it.
Fixed rate, yeah. There should be a way to set the interest rate at a global level. So later on, we're going to actually move the interest rate right out, but we'll get to that later on. So at this point, no, we don't have to modify anything. Do we have to add any? We can take the get account type method out because again, we're not going to have an account type anymore.
Which one did you
Sorry, account type. Set and get for account type we can take out because we're not going to have that. We don't need to have that anymore because we know what it is in the subclass environment. Set balance, get account number, set account number. The only thing we need to add is we need to interest rate. And we need to have a modification and an accessor method. So public void set interest rates. Like that. Is there anything else we need to do for, I'll get back to this code. Anything else we need to do for this? This class? Probably not at this point. So now, last time we were in class, we worked on the checking account class. So some key things just to remind you is that checking account in this case is a subclass of what we have from our superclass account. So the keyword here in this case is extends. The keyword extends account. So what we're saying is that our class checking account extends account, which means that account is more, so it uses everything that accounts have in it and extends it into this class. We do have an error message at this point because we modify our constructor to no longer worry about an account type. So we can take that out. And because we take it out in the superclass, we can also take it out when we're providing the data at the time of creation. So I'm just going to modify this a bit. I took it out from the checking account constructor, and as well as I'm taking it out about from this line right here. Explain what's happening in this line right here. What are we doing right here? What is the rule with a subclass constructor?
It's going down.
Yes, it's calling its parent, but why do I have to have that in there? Why do I have to have a super? So Gabrielle, you're right. It says super, and anytime you see the keyword super in an inheritance class, it is going to call its parents. You go up the hierarchy and find where this value is. In this case, it's looking at the parent class of this one, which is, what is the parent class of this class?
Checking account.
Checking account is this class. What's the parent class?
Account. It's not account.
Account? Okay, look.
Yes.
So look, we're here. What's the parent account?
Account.
Account, yeah, not checking account. This checking account is the class we're in right now. Account is the parent or superclass in this case. It is a direct superclass because it is directly above in the hierarchy. So in this case, we're extending account. What we're doing is just saying super means that in this constructor, we go to the superclass, go to the account class, and pass these values to it. So the superclass account get those values sent as a first line of your constructor. You have to do it. It is not a negotiation. You have to have that super call as your first line in your subclass constructor. If you don't have it, it's going to give you a compilation error. If you don't have that call right away, it's going to give you a compilation error. The only time you can get away with not having that is when? If I take this out now, let me just check something real quick. If I go into account. Yes. If I take this out and save it, it's not going to give me an error. Why? Why, like I'm telling you that this super call has to be the very first call in my constructor, but I took it out and it still works. What's the glitch? Oh, what's the reasoning behind that?
Because your constructor doesn't even.
Yes, I have a default constructor. So in your account class, if I define this, or if I don't have a constructor at all. If I don't have a constructor at all, Java's going to provide one implicitly for me, which is a zero argument constructor or default constructor. It's going to be given to me automatically. If I don't define a constructor, that's the one I have. That's the only one I can rely on, which means that Java will not show me in here that it's actually calling a non-visible constructor. It will be making a visible call to a non-visible constructor in its parent's class. That's why it works. Now watch what happens when I go back to account and I delete this and save. All of a sudden now I get an error message and I look at it. It says constructor account and class account cannot be applied to the given types. It requires double int. So if I try to run this, it's not going to work because it is missing that super call, which is the first call that the constructor has to have. Sense? Now, if I move it down, if I move that super call to the bottom of my constructor, what happens? Same thing. It will not compile because that has to be the first call that is being made in that subclass. So yeah.
Is it because Java has a sequencer or something?
No, it isn't. But I'm going to answer your question. Let's look at why we're doing this super call, and then we'll say, then hopefully we'll understand why it has to be the first call. Why are we doing this super call? What's the value? What's the point of doing this super call? Right? Why are we doing this?
Again, to recall values from accounts.
To populate values, to give values to
So
variables.
whatever it's created in account, now it's here.
Yeah, because look, we don't have, do we have a variable in this class checking account that's balance year, month, or date?
No.
We don't. We
have it in
do.
the account.
We do, but not directly. They're not defined in this class. Where are they defined?
It's an account.
In accounts. So they're in one level up. So because balance, year, month, and day does not exist in here, I don't have them. I can't reach. I'm not tall enough. I don't have them up in my variable declaration block. It's not. They don't exist. I don't have those variables. Where are they? In the superclass, which is account. Therefore, because they're up there, they are going to need data. Because if I have a superclass called account that has a balance, or I'm assuming it has a balance and a day, month, and year for creation, but I'm not giving it a value, what's going to happen when I try to call it? What's going to happen when I try to call that data? It's going to go up.
Once we say extends to account, isn't it a bit down to use super?
What's that?
So we say public class checking account extends account, so we already know that anything that we'll add here would be an extra comes from account. So why are we using super since it's already been defined at the top extends?
Well, we're just telling this class that we're extending from account. But the super call is saying, take these variables and send them up to the parent class. Make sense? So this is just a keyword that defines that we're going to go up one level in our hierarchy. So go to the superclass and give the superclass these values, these data values right here, and initialize them.
So when we use extends, what do we have at the time that we already we have within extends?
You're just telling this class that anything that is up in account is now available in here.
Yeah,
That's what
we have
extending.
account right now.
Yeah, no, we have checking account that uses everything account has. But this super call is saying, if I just took this out, what would this mean? Well, it can't be done. It has to, it's a method call, right? So it has to have a definition. And so instead of going account and creating a new account and setting up, I'm simply using the keyword super to define what I'm going up. This method call belongs not in here, in this class, but the class above, which is the super class. Make sense?
It does, but we still, I don't see what is extends and super. Probably already said that,
Well,
but I'm not following.
Yeah, no, the confusion here is that extends just tells me that this class is inheriting from here.
Yeah.
That's what
Well,
it
you
says.
just say it's his parent, but take nothing from there.
Oh, no, it takes everything from there. It takes everything from here and makes it available. But keep in mind, what if I didn't do the super call? What would happen?
Well, I thought also that was, but
Well, if I try to, if I, yeah, right,
The constructor would throw it, right?
it would throw an error, but let's say Java was gracious enough to say, I'm gonna let you run with it. Don't do it, what would happen? Yeah, there would be no data. There will be no data. The balance year, month, and date are here.
so
Balance year, month, and date. Those are the values I need up here in order to create the date and to create a balance, initialize the balance. Right here, balance gets the value from here. Creation date is year, month, and day minus 1. Year, month minus 1, and day plus day. So those values, this is happening right here in this constructor. So what I'm saying in my subclass is, okay, create a checking account. Provide all the data that you need, which includes all the data for the checking account, which is overdraft, balance, and interest rate, and everything that account needs. Why? Because we're borrowing all of those things from account. Account is providing that data for us. All the functionality and everything we need is from accounts. So when we're creating a checking account, we're not really creating a checking account. We're creating a checking account and an account. But they're consolidated because account has everything that we need to do in checking, but we're not defining, we're not rewriting it down here. So what we're doing is we're saying create a checking account class, a checking account object, and pass this data back up to the account. Make sense? Yeah.
So, checking account otherwise extends the account class, and the super call method creates that overlap between the two classes.
Yes.
For a specific constructor in account.
Yes. So what it does, really, this just backfills the data to what is above. Because if you look at those variables, do I have a balance variable here? I have an overdraft balance, but that's a different variable. Do I have a balance variable here? No. Do I have a date object in here? No, I don't. Where are they from? Where are they? They belong in the account class. And because the account class is gracious enough to lend me that data or host that data for me, it's not lending me the data, it's hosting the data for me. So my checking account has a creation date, it has a balance, but I'm not defining it. I'm not defining it in here. I'm simply saying, okay, give me the information. I'm not gonna host it here. I'm not gonna deal with it here. Send it up to the account, and then the account class takes care of that for me. When I need it, I can go to the account class. What's the balance? What's the creation date? And it'll give it to me. But if I, for any reason, don't send any data up here to the super class, so I don't send the balance, I don't send the month, year, and day in order to create an account, to create the data needed from the account class, and I try to access it, it's going to be a null value, and it's going to be wrong. That's what Java is saying to you. Yeah, if you have a constructor, the first call you need to make has to be to the superclass, the parent of the superclass of this account, this class, and pass the data it needs in order to work. Later on, you'll see if I have savings and I have a business savings account, and then from there I have a GIC savings account. This, when I create a GIC object, I have to have data that comes from account, savings, and business, and GIC itself in here. Then what I do is I send, okay, take out the account, the savings, and the business data, and send it up here. And then I drop up the business saving data here, and I send up the savings data and the account data up here. And at this point, to drop up the savings, and then send up the account data to this point. You're chaining your calls all the way up to the top. Make sense? Now, when I've done that, my next step is to take out overdraft balance and double interest rate and overdraft balance and assign those to the local variables that are down here. Why do I not have an overdraft balance and an interest rate variable in? Why do I not have an overdraft balance in account?
Because it's just for checking.
This applies to checking. Checking has, it means you're going to have checks attached to your account. You write a check, and the bank offers you something called overdraft balance. If you write too many checks, you don't have enough money to cover it. They will take care of it temporarily until you have a chance to deposit money back in. You have to zero balance or more in this case. So this is something that applies to checking account only. That's why we don't have. If that would have applied to all my accounts, where would it belong?
Superclass.
In the account superclass. Absolutely.
No, you're treating that though as a secondary balance though. Like you're
Overdraft
saying
balance?
overdraft balance, and as well, we've got the balance.
Mhm.
They're not separate, they're the same.
An overdraft balance and the balance is what you have. An overdraft, I guess it shouldn't say overdraft balance, it should say overdraft limit.
Yes.
Likely a better choice. Yeah, so change that to an overdraft limit. Good point. Now, an interest rate, when I create, later on as a lab, in-class lab, you're going to get, when we start talking about interfaces, you're going to separate all the interest rates into a consolidated area. Like it's going to use an interface, which we haven't talked about yet, but we're going to take all the interest rate and figure out what kind of account is it. We apply that interest rate based upon the type of account, but we'll get to that later on. So for now, we just put it in here, but we're going to take that out later. So overdraft limit is the amount of money you can go over, the money you actually have, without the bank saying, stop, can't do this, and keep an eye on it. So that's different from our balance. I'll give you 5 minutes to figure out the rest of this class. What else do I need in this class? and write it, I'll come around. What else do we need? We need methods. What methods do I need in here? I'll let you work on that for 5 minutes, and then we'll go for a break after that. I'll come around.
Personal.
Okay, sure.
Don't be coming regarding this.
There's no question.
No, no, sorry. Warnings.
Okay, so just checking against the type of account, you should know that use that. If you write a check, you know a check, right? Yeah, $20. So if you write, you write a check for $300, but I only have 250 on my account. So you can have those questions.
Yeah, this is a new thing as well, but years ago, it's something that is
You covered it.
total
Oh, I moved that. I use credit card and it's over. Mhm. All Europeans are the same, right? Yeah, it's different. Yes, yes, so the methods for this particular class, okay? Keith, no? No, good?
Yeah. Good. Just about good.
No, good.
I think we need another test.
We're gonna do more, yeah, we're gonna do more, say, just finish up the methods and try to No, actually, yeah, so good point. What I'll get you to do, if you're waiting, we're almost at break time, but when you come back, while we're waiting for everybody to come back, create all three. I want you to have a credit, checking, and a savings account that are all subclasses of account that all have some unique features, and we'll go through them real quick before I hand you the lab. So you're going to do more lab work in class about this, but you're going to work with customers as well. So that'll be your independent lab after. But if you finish up checking account with all the methods, start doing credit and savings. So this is a little bit of working independently, trying to figure out what do I need in a savings account that is different from checking, and what I need in credit that's different from checking. And then we'll go through it after. But try to if you finish this up, really all you need here is two methods, and then carry on working with the other classes and add the data and the variables to it so make sure it works. Now, can we get balance? Is there already get balance somewhere? If you look at account,
Yeah, taking.
is there a get balance in account?
No.
So open up, yeah, should be easy, but yeah. I'll come back to you. But we need to find. Um,
I don't know. I'm not really an expert on that. It's actually the confusion pretty much. So I'm just letting it there. Just Oh, yeah. No, people should have a memory of an old fish. What's the yeah. Long.
All right. Yeah.
I don't understand that, so all I did was.
You look at accounts. So, take your time, type
So I have no idea.
Well, now, you're extending from accounts, not from credit accounts. So what, look at your construction account, that's what you can say. Covered? And the accounts.
It shouldn't be a account.
You're going down.
No.
Safe cost dogs. Safe cost dog, well, you have capital service. Dogs. Yeah, come on. Visit.
So what does this mean?
Yeah, let's see. You guys can be nice. I'll come in 1 minute, guys. I will come back. I'm just going to point a couple things in for break. Sergey pointed something out which makes a lot of sense. Do we need an interest rate variable in here when we have one up here? We don't. So what we should do is we should require an interest rate variable or argument in our constructor up here. And then instead of doing this, we should simply pass that value up here and then take this out. Why do we not need one in both? It's not, and I want you to think about this. I don't want you to separate account from checking account at this point. Because when I create a checking account object, it's borrowing from accounts. But what is it borrowing? It's borrowing the things that are the same for every account type. So it doesn't mean that we have one object of an account and one object of a checking account and they work together. So we have one checking account object, and that checking account object uses whatever account you give us. Well, do we have interest rates to deal with in credit accounts? Do you have interest rate in checking? Yes. Do you have interest rate in savings? Yeah, nominal, mind you, but still, they have an interest rate, right? So by putting an interest rate variable down here, it's obsolete in comparison to, obsolete because we already have it up in account. Make sense? It doesn't mean that we're gonna have, it doesn't mean that if you create a checking account that the checking account is going to have an interest rate that's less because it's an account. No, it's just, we're storing it up in account. We can still set the interest rate in checking account to be whatever it is we need to be, and then it's stored up in account. Doesn't mean that if I have a credit and a checking account object that they share the same interest, because this will be an individual variable, interest rate variable here, and this will be an individual interest rate variable over here. Make sense?
Would you put in account, would you modify for the account?
Yes, the only thing you would have to modify an account is to add interest rates here, because we now have an interest rate variable right here. So we would have to go this dot interest rate equals interest rate, like that. Make sense? Really what we're doing is we're storing things that are same. So now what I can do is I can use this account class for credit, checking, and savings account. I can use that for all the values and then send them back and forth between super and surplus. Yeah? Yeah, I'll come see you in a bit. When you're finished, go take a break. Let's take a 10-minute break. I'm generous today.
So you can move it.
14 minutes. Let's say 14-minute break. We'll be back at 22.
What's good for you?
Okay, let me just
Yeah, it's a negotiation step, that's all.
negotiation
About
step.
the lab.
Yeah.
Can we
Oh.
extend the lab until Friday so we have Thursday's lab class to discuss it if we need to?
Exactly.
Hold on. a minute.
Food for thought.
Well, here's the thing. I see. The open lab.
Yeah.
The open lab is for anything. You can come in.
But it'd be after the fact of it being due.
Think about it. It makes sense, but
On that point.
I really think when you look at this lab, if you read it through and start just breaking it apart, take about 5 minutes to break it apart. I think some students started it already, and I think they're already finished it, right?
But the inclination though, because it's the first lab,
Yeah.
is to overthink.
Don't overthink.
Well-
Let me correct you right now. Don't overthink.
Oh, well, there it is, problem solved.
Yeah. Ellis. Oh yeah, I'll come see you. Okay, yeah.
It's very short. I want to show you something. There's no time whatsoever. And I have that like cross.
If you think sleep is a very rare benefit in your computer program.
That's what you just.
When I worked as a full-time senior developer, I go 4 hours, maybe 5 hours sleep, and lots of coffee. No, nobody said a computer program is healthy. Trust me.
Maybe I should change my once again.
That's gonna make a lot of money because you don't last very long. Yeah, Just check something. What version of Java do you have? Because it's zero. It's back to zero. Much better to do it if we didn't get any- some sort of thing that was not-
Ice cream truck.
I have money. It seems to be that we kind of get wrong. Yeah. So we started seeing. That should work. But that's not. It's working. There is a point telling that allows you, right? Yeah, I was doing some sure about that. You know, I found out. Okay, now I know it's in the wrong way, now the construction not happen, so. Fair enough. Yeah, this is the process involved. Open the code that I have on yeah. Now listen and then you do, okay?
General question. So why do we set the balance in the super class when each checking, savings, and credit are all unique balances?
They are, but keep in mind, when you create a checking account, the balance will be stored in the account, but it won't be for your checking account balance. Because it's an account, checking account off.
So-
It's stored further up.
So why wouldn't we create the balance in the checking account as a variable?
because that's redundant, because I need the balance could be consolidated into one class, so I have to rewrite it again in a subclass. It doesn't mean that all the balances are the same, it just means that this object has its own balance for its own account. Does it make sense?
Yeah,
So think about, I'm trying to draw a real life experience, for example. Trying to think of something that would make sense. It's hard, like, that's supposedly, I can think of a real life example. It's not, don't see it as account has its balance that's in shared in the whole. It's still an independent, encapsulated, variable, but it's protected up there.
Yeah.
But what we're doing, instead of rewriting every subclass, a new balance variable, a new balance variable, we're storing that there. So when we create a checking account, it's using.
so this becomes the style sheet.
Yeah, it has its own balance in checking account, savings and checking savings and credit. But what exactly, it becomes a style, because you can, but because they all have the same functionality,
Yeah.
just think of a car, the same thing. You start and stop the car the same way, whether it's a vehicle, whether it's a snowmobile, and so you don't have to reinvent the electrical system on how to transfer electricity from the battery to the ignition.
Right.
of the vehicle. You use the same, the battery, run wire, right, and then
I guess I'm just having a stumbling block because those ones I get, the balance is a simple variable. So it would make more sense in my logic, my twisted senses, that you create a variable in each account because they're distinct.
But they're not, the balance is, if you have a balance on your checking account, and give an example of the balance,
$25.
do you have that in savings?
You could in theory, but you don't. Your savings would be maybe $10.
Yeah, but conceivably you can, you have a $25 balance on your savings account. You have a $25 balance on your credit account. So they're all the same value, but instead of having individual variables that takes up enough space, you put that in an account, and you just, for every one of these, because you borrow it, you use this, and that's the same. What happens when it gets unique at the subclass level, that's when you put one, so, for instance, think about overdraft balance, or overdraft limit. Well, would you have that in savings?
No.
Would you have that in checking, in credit?
No.
It's only in checking account, therefore you put it in there, not at the account level. But because everything else shares a balance, but not shares a balance, but share the idea of constantly having a balance, then they will be in the account. It doesn't mean that they have the same type of balance, it's just that it's a balance, you keep track of the balance, and it's sort of each one. So think about it as, think about it like this.
This is gonna look odd, but checking, we call it checking, CH, object,
Yeah.
like this. Does that make sense?
Yeah.
So a checking has its own values, but it also includes everything that account can do.
Right.
There's two merged classes in that, for that class, for that object. Savings has its own unique things, plus everything account has. Why are we doing this? Well, because if I wanted to write all those account functionalities into checking, then I would have n amount of lines of code in addition to what I did for checking.
Right.
For savings, if I want to add all the account functionality without inheritance to savings, I would have to write all that code out in savings as well. Get
Right.
balance, all the things. Same thing with credit. All that data, those lines of code, the method, everything I did in account has to be incorporated inside this class.
Right.
So what I'm doing is I'm breaking that apart to make an account class that is lending all that data to those classes. So if I create a balance here, the balance is actually up here. So it's really an account balance, like from account class. Same here, same here. Doesn't mean that they have the same balance or anything is different. They're not unique in the set. A balance is a balance is a balance wherever you go.
Mhm.
What we do is we're just defining it up here to avoid having to define it in here. But all this data, all that functionality, all the variables are available to these classes. But when I create a credit account, it has its own set of variables and methods that account provides for it. When I create a savings account, it has its own set of data and methods, variables and methods that account provides for it. Same here. So which means that it doesn't mean that the interest rates, for instance, well, interest rates here is going to be different from here and from here, but they have their own copy of interest rate. It's just rather than rewriting it in our subclasses, we write it up here once and then borrow that code for each one of the objects we create.
Okay.
Does it make sense?
Yep.
Make sense?
Sort of, yeah.
Sorry? Okay.
Once I see the coding, okay, I'm following, because right now I'm still thinking, but it's just declaring a variable in the one object, one variable, because that's a unique, again, I'm having the mindset of, if my checking account is $25, my savings account is $10, and my credit card is $550. They're all unique balances.
And they have their own copy of that variable.
Yeah.
They have their own copy, but what inheritance allows us to do is allows us to, rather than writing this code 3 times for these classes, we write it once.
Yeah.
And then we say to this, okay, we know you're a checking account, but borrow everything the account knows how to do.
Yeah.
So everything that's common for all the subclasses are borrowed from this account. It's not that they're not sharing variables or anything. The only time you would share a variable is when you have the keyword static.
Right.
That's when it would be shared among everything. We don't have any static variables in this case, so you won't need it. What you're saying is $25, well, really think about it like this. Think about it, if I took all the code from account, all this code in here,
Mhm.
copy and paste that into checking, which I wouldn't advise, but
Yeah.
just make it a little bit easier to see. That in there, I guess. You take all the values from account, all the variables and all the data, the methods, and copy and paste it in. Like you would have to, because these do not exist in checking, right?
Right.
If you copy and paste those in here, now would checking account have his own variable, balance variable? Yes, it would.
Yeah.
Same thing for savings and same thing for credit. So they would all, at this point, they would have all the code copied into it. But imagine you need to change some code. Imagine you need to change, add a variable, take away a variable. Now you're changing it 3 times.
Right.
Whereas in our model, you do it once in account and it trickles down to everyone.
No.
So it is simply just avoiding redundancies. Rather than having to reinvent the wheel for checking, savings, and credit,
Yeah.
we create all those values once up in account. And then each one of these sub classes, checking, savings, and credit, can use what's up there because it's the same. Rather than copying it 3 times, you can use it because it's the same idea on all the 3 accounts. But it doesn't mean they share variables. They still have it. Rather than having been written in there, they're borrowing it, but it's still its own copy of the variable. Still its own copy of the balance, interest rates, all individual for those objects being created. It just borrows from the common denominator, or common source.
Okay.
Make sense?
Yep.
So think about it as a copy of this being sent in here, a copy of this being sent in here.
Without having to.
Without having to actually write it.
Yeah.
You just say, okay, I need it. There it is. The Java does it behind the scenes, but you don't have to write the code behind it.
Right.
Okay, makes sense?
Yep. Thank you.
I owe this marker back to testing services. I'm going to return this real quick and I'll be back, okay? So, because they closed at 7.
Tony, can I go with you?
No.
No?
Yeah, okay. All right, before we start. Is it in order? Yeah, it has to be in order. Okay. Yeah. You good for the lab?
Yep.
Yeah, so I think it'll be a super class. So see what it says. Okay, no. Are you extending your savings account from the account? If not, it doesn't know what to do. There's no super. What is it going to call? Just right there. What is it going to call? Which construction? You go with the class. Where is this? Oh, this. You just don't know. You don't see it. Okay, yeah, but there's no construction. It says it's kind of value and all this.
It's not the word.
Yeah. Okay, so that's what you. Yeah. Okay, because if you look at accounts, it's requiring more than balance of the actual variations. This thing that, okay, we're going to carry on. I'm not going to talk too much longer. A couple things I want to cover. We're going to have inheritance next week as well. We were a little bit ahead of the time before the midterm, so we started inheritance early. I don't think it's a bad thing, but we're actually not supposed to start inheritance until today. So this is sort of just a consolidation from last time. And we're going to have, I think, polymorphism and inheritance next week, which is just an extension. It sounds really scary, polymorphism, but it isn't. It's really easy and it's very valuable to know. It's just an extension of inheritance. And then we're going to start doing interfaces before we get into inheritance. So we're a little bit ahead, and now we start catching up. So we're going to do more about this for next week. Hopefully, I'm recording this. Hopefully, the recording will be working okay. For those who couldn't make it today, you can take a look at and follow along. There's a couple of concepts I want to cover before we carry on. So we've done superclasses and subclasses. The superclasses are more general. Typically, one step above, it's called a direct superclass. So what would be our direct superclass for this class? Account, yes, because it's our direct class above. And higher ups are called indirect superclasses. So an indirect superclass for this account, checking account class would be object, yeah, because it's up further in the hierarchy. So definitely. Now, one thing I also want to point out is superclass can have multiple subclasses, but a subclass can only have a single superclass. I couldn't have checking account inherit from customer as well. In Java, it only allows single inheritance, single line inheritance, which means that a subclass can inherit from a single superclass only, but it cannot inherit from multiple classes. There's a way around that. We're going to talk about later called interfaces. An interface is a lightweight class that you can tack onto any class to simulate multiple inheritance. But we're going to talk about those at a separate occasion, so I don't want to get into that right now. But so it's key to understand that they only allow one. Any subclass of a superclass has an is-a relationship. We already talked about a has-a relationship. A has-a relationship is what? What is the final word for that? Starts with a C. Composition, yes, composition. I was going to say it's compo plus ition, but you got it. Composition, that means has a relationship. Composition means that a car has an engine, a car has a transmission, a car has a gas tank, and so on. This case, This is a different type. It's an is a relationship. A credit account is an account. A checking account is an account. And a savings account is an account. Is a relationship. Now, what's also important to understand is that an account is not a credit account. An account is not a checking account, and an account is not a savings account. You can't trickle down in here. You can't go from general to more specific. You can't say that every account we have is a credit account. No, we have checking and savings as well. But all credit account you create is, every one of those accounts is an account. Subclasses. Why are we doing this? And we had some discussions at the front here during break. We're doing this because all of these accounts, all these subclasses have something in common between all three of them. So rather than rewriting the code 3 times for each class, rather than saying, write all the code in here that an account should be able to do, plus add your credit account functionalities, the same thing for these. Instead of doing that for each class, you're taking the things that are common for all the subclasses. So what is common between credit checking and account and savings account? Well, a balance, an interest rate, all the methods on how to get and set the basic information from an account. All those things are stored up here. Then what do we do with the subclasses? Well, there, for instance, checking account, we determined that it's going to have I don't have a pen, I have to give it back, but an overdraft limit. An overdraft limit does not exist up here because not all accounts have an overdraft limit. So a savings account doesn't have an overdraft limit, and a credit account doesn't have an overdraft limit because a credit account is an overdraft in its general. If you use credit, you're in overdraft at that point when you use it, right? Yeah.
Quick question about the subclass savings.
Thanks.
What does savings have?
So savings is simply just an account that takes. Savings. What was your question?
What does savings have that?
Yeah. So savings, it's simply an account that you put money into, and they give you a nominal interest for you to save the money in there. There's no. It's just money that you tuck away that you don't want to touch.
So what the variable be? The unique variable that I have.
You don't need anything.
So this.
Just a different type. There might be some features. So you might have a limited transaction amount. Because typically what you do for a savings account, you limit the amount of transactions you can have per month to discourage you from taking money out. Well, no, because a checking account, like for instance, I have a checking account that pays I pay all my bills and everything through, and then my wife uses it with a debit card. So if I wish I was limited, there should be a cutoff. Ooh, I'm recording under that. There's evidence against me. No, but a checking account is like you pay bills, you transfer money. You write checks, you do all sorts of. You don't want a limit on that because that's your utility account that you take care of your business, so to speak. Whereas a savings account is you put money in and hopefully leave it there in order for it to expand and grow. Not a good idea. But don't take my advice of going with a savings account. It's actually a horrible idea. What you should do is invest your money with an investor, and you'll probably have better growth. However, if you don't, and if you want to tuck away some money every month or every week or however you do it, the savings account should have a limited amount of free transactions, so you can take some money out when you need it, but not spend back and forth in the savings account all the time. So there's transaction changes for the savings account that are slightly different. I'm not a banker, so I can't necessarily say what else is unique about a savings account, but I know I have a savings account where I put away my coffee fund, I call it, that no one knows about, and then all of a sudden.
Did you know?
Should have warned me. No, I don't. No, but it's just something that I have. That I do investments with a professional investment company. That's my investment part. But I have like a little rainy day account, like a coffee fund, just for fun, right? So that's beside the point. But I don't necessarily know the difference. What other than transaction limits, because I have 5 transactions per month in that account, and then it starts charging me. And I'm not cheap, but I'm frugal, which means I'm not going to use that account unless I don't have to. So I just let it sit there. Make sense? Okay. No, I completely lost what it was. Yes. So all these have unique features that applies to them, and you just use the top level account or superclass to make sure you know how to work with it. So I mentioned a subclass can only be derived from a single class, superclass. Now, what's key to understand, and we're going to go over this a little bit more next time. We talked about constructors. A constructor down here. So if you have a constructor down here, let's say what are the variables we need for an account class at this point, my account constructor?
Balance. Interest rate.
Yeah. Year and day. That's it, right? So if I create an account class or an object of the account class, this is the data I need to provide. I need to provide as arguments to this class up here, right? If I create a credit class object, I also have to give a balance. I also have to give interest. I also have to give year, month, and day. What is unique with a credit account when I create it that's more specific than a regular account?
Overdraft limit.
I'd say credit balance or credit, what do you call it?
Credit debit.
The credit debit, that's the process of working with it. But what is
Credit limit.
credit limit? Thank you. So in here, what's unique is the credit limit. What else? Is that it? Let's leave it like that for simplicity. So credit limit is unique for credit account. So in this constructor, I need to have all the things I need to send up to my account class plus what is specific for my subclass, which is the credit limit. So I have all these values that I need, because if I'm inheriting from account, these are the variables I need to give to account. And those are the variables I need to ask for in this constructor down here. And then what do? I use a super call. We'll put the super on this side. It's going to be hard to see, but. And then all the data that I'm asking for when I create a credit account, all that data that is borrowed or used from the account class is taken and sent up to the account constructor. And all I keep down here is my credit limit variable that I'm asking for in the constructor. That's why the constructors, the further down the line you go, the constructors will grow bigger and bigger and bigger. That's the only thing that grows in an inheritance hierarchy. The code grows smaller and smaller and smaller the further down the line you go. Because everything you need down here is borrowed from this, and this class. So all you need down here in a GIC class is something that's very unique, maybe one, maybe two things that are unique for that particular class. Everything else stays above. Make sense? Yay, nay? If it doesn't make sense, we'll carry on. Yeah?
What's your role? Is that Thursday? Is that going to be every day Thursday or just that?
As I said, I'm on vacation this week. Normally, I take the vacation right after a week of vacation right after reading week, so I can help students catch up if they need. But because we had the midterms, I didn't. There was no value in doing that, so I pushed my vacation up to this week. So there's gonna be a week of vacation from everything else I do, and I'm available to students for help this week. So it's a one-time for this week only. I'd like to set up more labs, but my other job schedule is so dynamic that I can't. But this week for sure, it's just an open lab that anybody can drop in. So if you have other questions that you can't make the lab time, just shoot me an email and I'll set up like an online session. We can talk about it as well. Okay. But does this make sense? Does this make sense right here? Why we're passing if I'm passing this data up here, I need to ask for it as well, which is why I put it in my constructor. So if you look at your constructor in our case, a checking account, what am I asking for? Balance, int, balance, year, month, day, overdraft limit, and interest rate. What am I sending up? Well, balance. I'm taking that value, putting it in here. I'm taking interest rate, putting it in here. Taking year, month, and day. Here, and I'm taking all those values, and where am I sending it? Well, I'm doing a super call. I'm calling the superclass constructor and sending the data up. What happens to it when it gets sent up to account? Well, let's go back and take a look. I'm taking all the data and I'm assigning it to the variable I created up here. And now the data is available. I just have to go to account. If I want to find out what balance is, I go to the account superclass and say, hey, give me the balance for my checking account. It will give it to you. If I want to find out the creation date, hey, give me the creation date, and I can get it. How do I get it? How do I get that data? How do I get the data? All the data, there's balance, account number, interest rate, and creation date are all up in the account class. How do I get that data? Super keyword is sending it up in the constructor. How do I get it? Call the methods. Because remember, the methods from account is also available to me. Do I have anything here that can get the balance? Right there. And what is it returning? The balance. Oh, I shouldn't do that. What happened there? Okay. My mouse pad doesn't work occasionally, so I have to use my little, anyways. Get balance. Now this get balance is going to go to account and say, give me the balance. Why can't I go directly to the variable? Why can't I use the variable directly?
Private.
It is private, absolutely. The variable is private and still protected, still encapsulated into this class. So even though I'm extending from it, a private variable in any hierarchy. If I make a private variable any along here, it belongs to that class. It can be accessible by that class only. Therefore, we need to create methods in order to access that data. So how do I do it? I can go super dot get balance or just get balance, because they're all available to me in my subclass. And that's in the checking account. Public variables. Public variables are available throughout the entire hierarchy. We never use public variables, very rarely do we use public variables because they're not a good practice. Private variables are unique to the class. If I have a private variable up here, it can only be accessed in accounts, so which means I have to create a method to accommodate it. There's one more. Access type. Access modifier. Private, public, and protected. Here's one of those situations where protected is applicable. Protected, if I make a protected variable in here, it is available throughout my entire hierarchy, which means down here, I can access that directly by variable name. So protected variables are accessible in an inheritance hierarchy or in the same package that you created it. Is it good practice to use protected variables? You'll have two schools of people say two different things. One school will say, yeah, absolutely, you can access it. Other people will say no. Here's why I don't like it. Here's why I don't like it. Let's say I create an account, I create a balance, and it's protected. And down here, I'm going account dot. Actually, I can go directly. I can just use, in this case, I can use balance directly. Now, we said I couldn't use balance in checking account before if it's private, because it's a private variable that only belongs up here. But if I make it protected, I can reference the balance variable directly. If I make it protected up here, I can reference the balance variable directly down here, because it's protected. It means that it's protected from anywhere outside. Customer couldn't come in and say access balance. Nothing else could have. Anything inside that extends from account can use it directly as if it were to be a public variable. What's the danger with that? Why do we not do that? Well, you might want to. You definitely want to change the balance. You don't want the balance to be. You can, but that's the whole point. That's the whole point. That's what the one side of this says. Yes, you should make it protected because it's easier to modify, which is what we want to do. So in that aspect, it's not a problem. Otherwise, making it public is going to be a problem because, if it's public, it's a huge problem because anybody can go in and change that balance on the outside. So never public. But making it protected, it'll act like a public variable in here, which is okay. Not okay, but more okay than definitely using public. But why is it a problem?
So say somebody knows that there's a class checking account, they make a class that extends checking account and say access whatever variables are in there.
Unless you make this class final, you can extend from it and then you can absolutely have access to the balance. But that's not what I'm thinking of, because you can security-wise, you can set that up so you don't have a problem. But imagine we use balance as a variable throughout all these classes. We're actually using the balance variable throughout all the classes. And all of a sudden, we're up here, and we realize, you know what? We need to change that to account balance, adding ACCT in the front. Now the entire hierarchy line will break because you're not accessing account balance anymore. You're accessing balance, but that's a variable that no longer exists because you changed the name. Now you're defeating the purpose of inheritance to simplify your code. How do you get around it? Well, don't make it protected, make it private, or if you have to have it protected, instead of accessing balance, the variable directly, go get balance, the method. Because get balance, the method, now I changed the variable, and the method inside of account will also be changed to return account balance instead of just balance, 2 lines. And your entire hierarchy will still work.
Yeah, no, that's fine.
Make sense?
Yeah.
So that's why that's what my side is, and the school I'm from is don't use protected in this case because you're going to put yourself into a situation. It just generates sloppy code, sloppy practices that you don't want to have. You want to make sure you stay as rigid as possible with your code. Your code is always protected, no pun intended, protected and well managed. So the 3 ways to access the 3 access levels are public, private, and protected. You can, and definitely not public. I don't ever want to see public variables ever unless it's a final variable that can't be changed. But definitely protected and private. But I prefer private over for this particular reason. It could cause glitches for you later on. Now, let's go back and look at our account class. And we're going to create a method in here called public double calculate interest. Very simple way to do it. We're simply creating a calculate interest. What is it? Well, we're going to return what? The balance times the interest rate. That gives us the interest. At this point, do we have an interest rate? Well, we will when we set it. So when we create an object, it will be set through the constructor and be sent back to the class, to the account class to be initialized. Is this? Let me ask you this: do you calculate interest on all levels of accounts? Not type. Do we calculate interest? It's the question. Do we calculate interest on all levels of accounts? Yes. Do we have interest? Do we have credit interest? Yes. Do we have checking account interest? Yes. Do we have saving account interest? Yes. Here's my question. Do we calculate interest the same for all 3 accounts?
No.
So no. So we can store the interest rate variables and the balance variables in the account class, but we cannot rely on the same method to be calculating interest for all different kinds of accounts. How do we fix it?
Have a very calculated interest.
Nope, because now you're adding variables at every level, and that's against practice of inheritance. Methods? Who said methods? Yes. How and why? How and where, sorry.
Because if you use the interest rate variable and create different methods in each class.
Ah, you're partially correct. You can create methods in the subclasses, but what you're doing is you're using the same method, but we're using something called overriding. Previously, we talked about overloading. What is overloading?
So making more than one method with some name with different parameters.
Right, so we have, in fact, we've overloaded constructors. The same constructor name, but we're changing the variable amounts or order of variables or data types in it to make sure it works. If we have the two methods or two constructors with the exact same signature, same name, and same variables, same types, it's going to cause a problem, right? Because it doesn't know which one to call. That's overloading. Overriding is taking the exact same method in the subclass and overriding it, but just changing the content. So everything will be exactly the same. It will be public double calculated interest, no arguments. And then instead of here, we would modify our interest rates, our interest calculation slightly different in our subclasses. How do we do it? Well, let's go take a look at our class. So at this point in our account class, we have an calculate interest, which is generic. What I want to do in my checking account is I want to create an override. What you do is you use an @ sign and go override with a capital O. @ override, and what am I overriding? Public double out. So and it might not be so applicable here, maybe because well, it actually will. We're not going to get too granular, but how would a checking account interest calculation differ from, let's say, savings? Even better. Let's do credit. How does a credit interest calculation differ from let's say a savings?
It's compounded monthly,
Right. So you get my understanding is you get 30 months,
30 days.
30 days or a month worth of grace period on the money in your credit account, whereas in savings account it's take a date, however much is in there at that point. That's your calculated interest. Make sense?
Mm-hmm.
So here, we're just not going to simply return. We're going to write some code. I'm going to put return. For now, I'm just going to put 0.0 to get the, we're going to write logic. To calculate the interest first, and then return the value. Of course, it's not going to be return 0.0. We're going to change that. I'm going to store it in a variable. Same thing with credit, same thing with savings. So, but notice the key here is I have an @ override notation. That tells Java that, okay, I know there is a calculate interest up in account, but I'm changing that. I'm creating a new calculate interest now, and I'm going to do something different. So whenever for this object, I create a checking account object, and I want to do a get balance. Well, the get balance is going to go up to account because I don't have an overridden get balance down here. So the get balance is going to go up to account and use that value to return the balance. When I change the balance for my checking account, it's going to change the balance variable in my account class. So when I get and set the values from my balance, it's going to use the methods in account. When I have a checking account, in this case, and I'm calling the calculate interest method, the Java is going to look at, okay, it's a checking account object that inherits from account. Account has a calculate interest method, but so does checking account. Because checking account has one that's been overridden, it's going to disregard the account class calculate interest method and use the checking account class calculate interest, and therefore get the correct calculation of interest at that point. Make sense? Overriding simply allows us to be more granular in our subclasses of what operations we want to do. So that's when we get into looking at everything that's generic up here that might not apply to these. We have a way to fix that. We can go and create an override and those methods. So we can do a basic calculate interest for savings, because all we do is figure out at one point of the month, we can look at the balance, we can look at the interest rates, figure it out and return that to whoever needs it and apply it as an interest. Whereas credit, we're going to look at transactions that are more than a month old times the interest rates, and then create that becomes the interest, compounded interest at that point. Whereas anything newer again, 30 days, will not be included in that calculation. Two questions. So we got to welcome back to the thing. Yeah.
So as I understand, override is really an exception. So do this method instead of the one that is in the account.
Choose this.
In the checking account.
Yeah, choose this because it's more unique, or it applies. This is the one we want to use rather than the one in the parent class. Okay,
If you didn't use override, it would have thrown an error because which one?
no. If I take
Override.
if I take this out,
Yeah.
it's not going to throw an error. It's going to give you a warning that says add override notation, because you don't have to have it in there. This is just NetBeans barking at you and saying, hey, follow the protocol.
But I mean, it's an account. Would Java be confused, as you say, which one do you want to use?
That's polymorphism. We'll talk about that more next week, so don't get too heavy. So polymorphism figures out at runtime, what type of object is it? I know it's an account, but it's a checking account. What type is it? And it's like, okay, it's a checking account, therefore go here to calculate interest rather than to account. Polymorphism. Java is pretty smart. It's a pretty smart language. I can figure that out. I'm going to put that back in.
Okay, so in a situation, say for example, the credit, checking, and savings all had different methods of calculating the interest, then you wouldn't put it in the account because it's distinct.
If they, okay, this is a great question. So if all of these had unique ways of calculating interest, you would still put it up there, because later on you might have a business account.
Okay.
It's not all inherited classes might take advantage of a unique way of calculating interest. A student account, for instance, would be likely the same thing as a savings account.
Right.
Would be likely to be the same thing as a senior's citizen account. I'm just
So
making
this
stuff
is
up.
the generic, absolute basic, and then any situation where you stray from that, you would do the override.
Yes. Consider this, a really good example of this, let's say employee. We have an employee class at the top level. And then I have a part-time employee, I have a salary employee, and I have an hourly employee, salary employee, and commission employee. 3 types of employees. All get paid differently. In my employee class, I have to have a way of calculating pay, but my subclasses, hourly, commission, and salary, that it's a completely different way of calculating pay. Therefore, they all be uniquely overrated. But then I can add a seasonal employee, which might use the generic one. I can have just an employee. Later on, we're going to find that we actually can't have an employee.
We can't have an employee?
We can't have an account either later on.
Awesome.
If I run in the bank, or if you run a bank, and you say, these are the 3 types of accounts I offer, and I come in and say to you, Keith, I'd like to open an account. What would you say to me?
Which type?
I want an account.
Okay.
Which one are you going to give me?
The credit one, because it's.
You're going to make more money. And that's how you end up in front of, that's how you get to go to court.
Awesome.
No, but you can't have an account because it's too generic.
Right.
Because you're trying to create an account, but no, wait a minute. I need you to create credit, checking, or savings account. And I want an account. It's like going into the pet store saying, I want an animal. And they say, well, okay, pick one. No, just give me an animal. And they're going to say, well, what kind of animal? I say, I want an animal.
you start getting aggravated, and then security escorts you out. You'd like to get a fine for being,
Or you've bought $1,000 German.
but the point is, you can't just buy an animal. You have to buy a specific animal, a chameleon, whatever it is you want to buy, right? So later on, we'll find it. I'm not going to get too far into that. So the remaining time, finish up these subclasses. I also want you to, we have in our class collection, we have customer IC. I don't know why we call it IC, but let's roll with it. Customer IC. I think it was in class. We have 2 customer classes. You can consolidate these two to whichever one you want. You can either keep the customer one. This has some data in it, some methods. This one is customer IC, has some more data. Create one customer class that has all the getters and setters you need for a customer. I'd say use customer IC, change the name to customer, delete the other customer, and add the gets and sets method in here for customer. And then I want you to create a business, customer, student, customer, and we'll start with those 2 for now as extended classes. Make sense? So finish up these first. Make sure you have all the unique things in here. I want you to override the interest calculation in each one of those subclasses. Make sure that you have variables, whatever is unique for credit, checking, and savings. We talked about that for the past hour and a half. Make sure you add those in. Then when you're done, I want you to do the exact same extension on business and student on customer. And that'll be the rest of our class, about 25 minutes left. I'll walk around for those who need help. On top of that, this is nothing that's due or anything. It'd be really fantastic if you can finish this up for next week to have it ready so we don't have to spend time waiting. I know we have another lab that's for marks, but really I'm trying to encourage you to write as much Java code as you can outside of class because you're going to need it for the final exam. So if you can finish these 3 account types and 2 more student classes before the end of the class today, that would be great. If not, take it home and finish it at home and bring it here for next week. Be ready to go. I will post the solution to it on Blackboard. I'm going to finish up my homework. But also on top of that, I'm going to bid you to take a look at this lab right here. It's under labs on Blackboard. This is a lab that's due on Wednesday by midnight this week. It's simply design a class named person with fields holding a person's name, address, and telephone number. So a class with how many variables? 3. 1 or more constructors. That's a clue that I want a default one as well as one that's overloaded, typically. And an appropriate mutator and accessor methods for the class fields. So what is an accessor method? Get. What is a mutator method? Set. So get and set methods for all the fields, which is name, address, and telephone number. Next, design a class name customer, which extend the person class. Should have fields for a customer number and a Boolean field indicating whether or not the customer wishes to be on a mailing list. So that's, again, keep in mind, you have to do something with the construction to make that work. Right, 1 or more constructors and the appropriate mutators and accessor methods for the fields. We're done. We got lots of time. Don't rush out. I'm just showing you what I want you to do. And then create a main program to demonstrate it. Create a customer and a person. And then maybe print some stuff to the screen. This is testing. That's your opportunity to test. When you test, by the way, I noticed this in assignment 1 too. When you test your data in a test class, do as much testing as you possibly can to show me you know what you're doing. Some of you lost marks because you were only starting the car and changing the gear once, and that was it. And the assignment outlined clearly that you needed to change, start, stop, change the gear, open doors, all those things which need to be tested, right? So if you didn't get full marks because you omitted that, because you look exactly what I'm looking for. In this case, there's no definition, but my expectation is always test as much as possible, because that's how you're going to find potential glitches.
Questions? All right, so start with these 3 classes and those 2 extensions in class, and then this is your take-home lab for Wednesday at midnight. Question? All right. Yeah, I'm gonna 2 questions without coming on, okay? Okay. I'm going to stop the online recording at this point because there is no more lecture style going on. So I'm going to save this